Hello, welcome to the Cluster API Deep Dive. I'm Cecile Robert-Michon. I'm a software engineer at Microsoft, and I am a Cluster API Azure maintainer. I've been working on the Cluster API project for about a year now.
And I'm Naadir Jeewa. I'm a member of technical staff at VMware. I'm the maintainer of the Cluster API provider AWS, on which I've been working for about 2 years now.
So, a sub-project of SIG Cluster Lifecycle. It was initially released in V1 Alpha 1 in April 2019, and it's now in the V1 Alpha 4 API version. And Cluster API is a Kubernetes project to bring declarative Kubernetes-style APIs to cluster creation, configuration, and management. What this means is that it really simplifies the lifecycle management of Kubernetes clusters using extending the Kubernetes APIs. And if you're not familiar with our logo, it's a reference to turtles all the way down because it's really using Kubernetes to build Kubernetes. Okay, so when talking about Cluster API, it's important to understand that it is a building block. So there's this project called kubeadm, or kubeadmin or kubeadm, depending on what your Kubernetes pronunciation game is. But it is another sub-project of SIG Cluster Lifecycle. And what kubeadm does is it takes a computer, a server, a machine, and it turns that into a Kubernetes node. So it really simplified and streamlined the way that we build Kubernetes clusters in Kubernetes. What we did with Cluster API is we went one step further. We took kubeadm and we built on top of it using it for bootstrapping of nodes. And we decided we wanted to also manage the cluster infrastructure itself using Kubernetes APIs. So that's what Cluster API is. And it is modular, which means that you can replace build your own provider for bootstrapping, for example, or use another existing provider besides the reference kubeadm provider, such as the Talos bootstrap provider. And you can also plug it in with any infrastructure provider. So that means it's compatible with any cloud or any on-prem environment. In Cluster API itself, the lifecycle management part is really environment agnostic. This is a bit of an overview of the landscape of the infrastructure providers and bootstrap providers that exist in Cluster API today. This is just an overview. As you can see, there's support for some of the major clouds, as well as some bare metal providers. It is a growing list, so I recommend you check out the full list at the Cluster API book in the provider section. And if you can't find what you're looking for, you can also decide to build your own provider. We have some instructions on like a provider contract on what is needed in order for your provider to be conformant with Cluster API. Okay, so how does it work? So when thinking about Cluster API, there are usually two ways that users go about using the tooling. The first one is having one management cluster and many target clusters. What that means is that the management of your target clusters is centralized and is all on one cluster called the management cluster. The management cluster can be any Kubernetes cluster as long as it's Kubernetes conformant. So you can use kind, or you can use a managed Kubernetes service such as AKS or EKS, or you can use another Cluster API built cluster. And then your target clusters are what runs your Kubernetes workloads. What's really interesting about this is that you can actually have different environments being managed from the same management cluster. So in this example, we have Azure clusters and OpenStack clusters and AWS clusters and vSphere clusters all being managed from a management cluster. So let's dig in a little bit more into the management cluster. So there are three providers in Cluster API. There's the core providers, the bootstrap providers, and the infrastructure providers. And then we also have control plane, which is a new addition. So how it works is Cluster API uses CRDs to extend the Kubernetes APIs to manage clusters themselves and their machines. And it uses controllers to reconcile those CRDs and make sure that the actual state of the world matches the desired state. If you're not familiar with controllers and CRDs, I recommend checking out the KubeBuilder book. I think it's a really good introduction to the basics of how CRDs and controllers work. Okay, so I mentioned that there are two ways of managing cluster API clusters. The first one is having one management cluster and many target clusters. But what if you just want that one Kubernetes cluster? Sometimes you might not want to have an extra cluster sitting there to manage your workload cluster, and you might want to be able to manage your workloads from the same place that you manage your cluster infrastructure. And that's where the self-managed cluster concept comes in. So how that works is, as a user, you'll start by bootstrapping a cluster called the Bootstrap cluster. And that's, again, any Kubernetes cluster, as long as it's conformant. And that cluster you will install all the cluster API CRDs and controllers on it. And it will start to reconcile your target cluster. And as soon as the target cluster control plane is up, then you do something that we call pivot, which is you move all your cluster API CRDs and controllers to your new target cluster, and you delete your Bootstrap cluster. That means from that point on, you're going to be able to manage all your cluster infrastructure from the same place, from the cluster itself. So you really have one place where your cluster workloads and your cluster infrastructure is managed from. So I'm going to give you a bit of an overview of the CRDs and their specs. I'm not going to show you all of them because that would take a long time. But just to give you an overview of the important ones, this is the cluster. So the concept of cluster is, so this is in Cluster API, it's the cluster-wide configuration. And it is everything that is really generic and not infrastructure specific. Things like pod and service ranges. And then we also have the associated infra cluster. And the infra cluster is per infrastructure provider. So usually it will be named like something like name of the infrastructure and cluster. So for example, AWS cluster, or Azure cluster. And that's really the provider specific cluster configuration. So for example, your AWS region or your Azure location or your VNet name or things like that. Then we have KubeADM control plane. So I mentioned control plane provider briefly earlier. KubeADM control plane is new in V1 Alpha 3, and it is a way to simplify the control plane lifecycle management using KubeADM. So it has the replica count, which is the desired number of control plane machines. And then it has two references, the infrastructure template, which is what the template of the infrastructure machines and what each machine should look like. So a reference to that template. And then the KubeADM config. And the KubeADM config is really what helps you configure the bootstrapping and the cluster configuration. So you have the init configuration, the cluster configuration, and the join configuration. And that's where you would set things like if you want, for example, extra arg in your controller manager. And then we have the machine deployments. The machine deployments are, if you're familiar with pods and deployments, machine deployments are kind of the same thing for Cluster API with machines and machine deployments. And so with a machine deployment, you can define a set of machines that would have a similar configuration. And you will set a replica count similar to the control planes. And then you'll also have the machine spec, which defines what each machine in that set should look like. So that will have the kubelet version and the reference to the infrastructure template, as well as the bootstrap template. Okay, and then we have machine. So a machine is an individual object in a machine deployment, or you can also decide to create individual machines, standalone machines, just like in Kubernetes, you can create standalone pods that are not part of a deployment. And so this is really the configuration for that specific machine, and the spec looks very similar to the machine deployment spec. We also have the kubelet version and the infrastructure reference, as well as the bootstrap config reference. And then just like you had the infra cluster with cluster, we have infra machine with machine. And so infra machine, again, is going to be something like AWS machine or Azure machine or vSphere machine or etc. And in that infra machine, you really have all the infrastructure provider specific configurations. So those are more like environment specific capabilities. So for example, if your provider enables Spot virtual machines, that's where you'd configure that. You'll be able to set your instance type or your VM size, depending on what cloud language you speak, and different things like that that are really provider infrastructure specific. Okay, so now I'm going to hand it off to Naadir, who's going to show you the exciting part, the demo.
All right, so what one through is how to get started with Cluster API essentially. So what we're going to do is first going to use Kind to just have a bootstrap cluster that I can work with. And then we use a tool called Cluster Cuttle, which you can get from the link below. And this Cluster Cuttle in it installs the components that are required to run Cluster API for each provider. So we're actually going to set up 3 different clusters at the same time using Azure, AWS, and vSphere. So this really shows the power of using Cluster API. So to create a cluster, we use a command called cluster cuttle config. And this just generates Kubernetes manifests, templates that have been released by the infrastructure providers that help you get started. But there's nothing to stop you using your own manifest using the specs that Cecile showed a few moments ago. So this is just an example of each of the Azure, vSphere, and AWS templates. And they all have common components and then each custom bits for each individual infrastructure provider. And then what we're going to do is we're going to apply this to a bootstrap cluster, which in this case is the Kind one we just created, just showing the logs from each of the sort of controllers for each infrastructure provider so you can see what's going on. And the first thing that happens is that it creates the sort of underlying network infrastructure that's going to be needed for the cluster. So usually load balancers. If it's public cloud, then anything to do around creating private networks. So that's VMnets in Azure and VPCs in AWS. And we can also just use normal kubectl, kubectl to inspect the objects that are created by each of the Cluster API components. So in this case, we're doing kubectl get KCP, which is the kubeadm control plane management and the various vSphere machines. Next thing you do is the cluster config, the administrative login is stored as a secret, so you can just get that out and use that with kubectl to access that newly created cluster. And the first thing we need to do is apply like a CNI. So Cluster API in itself is not opinionated in terms of which CNI you use. So we're just using Calico in this experience. And now we've had a problem, is that one of these Azure machines didn't come up. And that's because I don't have enough quota in my Azure account because I started it several hours prior to making this demo. So what I'm just going to do is just edit the machine deployment. So I'm just going to make it 2 rather than 3. So then I have enough room for my high availability control plane. And then you can see, just delete that faulty control plane machine and Cluster API goes ahead and replaces that for me. The other thing that I want to do is my AWS cluster is a bit out of date compared to others. It's 1.17 versus 1.18. So I want to basically upgrade my AWS cluster. So I can do that by editing first the control plane and just changing that version field. So you can just change it from v1.17.5 to v1.18.2. And once I've saved that and exited, you can see that what's happening is one of my control plane replicas become unavailable because it's about to be deleted. And I've got 4 replicas rather than 3. So it's created one new 118 control plane instance. It's checking etcds working, making sure that the etcd cluster is okay, and then it's just going to roll through each of those control plane instances, replacing them one by one. And the other thing we can do here is, like, I can do this independently, so I can also upgrade the worker nodes. So I'm just going to edit. So the worker nodes are controlled by the machine deployment. So I'm also just going to change that to 118.2 and exit Vim. And you can see that nodes are going to not ready, scheduling disabled. So we're doing the draining that node, making sure the workload's moving off, then terminating that instance and replacing it with a new one. And you can control using the standard sort of max burst sort of settings that you're familiar with in pod-based deployments. You can apply those there to control how many machines get replaced at once. Finally, we're just going to show this pivot method. So what you might want to do is, you've created a cluster with Cluster API. You want that to be the management cluster for all of the other clusters. So what Cluster Cuddle Move does is it pauses all of the resources on this initial Kubernetes cluster. And after we've installed run Cluster Cuddle in it on the AWS cluster, which is where I'm going to move everything to, you can then run Cluster Cuddle Move, and it basically deletes the objects from the old cluster and puts them into the new one in this paused state, and then unpauses it. So then then you can continue with ongoing management. Finally, just want to show how you might want to do development Cluster API. So we're big fans of using tilt in development. So tilt allows us to essentially do hot reloading as you write code using Cluster API. So there's a JSON file that you can see in this VS Code that you will need to set up. All the instructions are on the Cluster API website. And then what we just do is just change a line of code. You can view all the logs in the browser as well, so you can just click on each of the controllers that you're working on. And in this case, I'm just going to change one log line, and you can see that the controller got rebuilt and started again. So this is most of the sort of Cluster API developers are using this. Tilt's a great tool for all kinds of development. We use it extensively in Cluster API. So with that, let's talk about what we've been working on. So we've just done some new releases of Cluster API. So in this 0.3 series, we've done quite a lot of work. One of the things we just introduced was the control plane management, which I just demoed a moment ago. So this is really about making sure that we can do day 2 operations of clusters managed by Cluster API in terms of being able to do upgrades, remediate control planes, being able to scale them up. So you maybe started off with a demo one node control plane cluster, but it's actually running production workloads, make it high availability. That's what the control plane controller can do. The machine pools CRD is a new thing that was added in 0.3. It's implemented for Azure right now, with AWS is coming soon. And that's where you have cloud providers that provide their own constructs for sets of machines and provide more enhanced functionality through those, such as in the case of Azure VM scale sets or AWS auto scaling groups. They can be used as a native construct within Cluster API. Machine health checks allow you to gives a pluggable model for remediating machines. So you can use any tool that you're using, such as Prometheus or a node problem detector, to mark nodes as unhealthy, and then that can act as a signal for Cluster API to do some sort of remediation. We've done a lot of work on testing. So we've built if you're writing your own provider, or you're working on other bits of Kubernetes, such as CSI or cloud provider integrations elsewhere, then the Cluster API test framework provides some really nice helpers and abstractions for you to just start a Kubernetes cluster, run some tests on that cluster that you created, tear it down again, and just run things like conformance checks, etc. Failure domains. So this is introducing the concept, particularly for the Kubernetes control plane, around what are the different failure domains within a given infrastructure provider. It's a way to give that information to the core controllers, such as Kubernetes control plane and machine set, to be able to distribute instances across those various failure domains. Cluster Cuttle, cluster control, cluster CTL. That got a complete rewrite in 0.3. It kind of disappeared for a while in 0.2, come back again as this, and that's really that utility I was showing you earlier. So the ability to install infrastructure providers, the latest releases, without having to deal with lots of walls of YAML. That's what cluster CTL is all about. Conditions are, if you've worked with nodes or pods and you've seen conditions on those objects, we've now introduced them into the cluster API resources as well. This should really help people who want to work with those resources more programmatically. It gives a much cleaner interface in terms of introspecting what is really happening inside a given cluster. And finally, we've got initial cluster autoscaler support. So this work is ongoing within the Cluster Autoscaler project right now. So it will be able to control machine sets in Cluster API generically. So it doesn't need to have any infrastructure specific information. And you'll run this as one part of Cluster Autoscaler in your management cluster, one part in your workload cluster. And the autoscaler will be able to control will be able to scale up and down a clusters managed by Cluster API. So given that, there's what's next. So we're hoping to reach beta status by the beginning of next year. So we're going to be working on stabilizing Cluster API and make sure it meets the needs of everyone who wants to use Cluster API. Ongoing UX improvements. So we did a big rewrite of Cluster CTL. We want to improve that. Not everyone wants to use Cluster CTL, so how can we improve that experience overall? Better management of cluster add-ons, so things like CNIs or those sort of core DNS or kubeproxy, those core components that every cluster needs. We introduced something called a cluster resource set experimentally. So that's the ability to, as soon as you create a cluster, apply a set of manifests to clusters based on some labels that you've set on them. Detections of machine failures prior to cluster join. So one of the problems we have now is we only really know the status of the machine once it's joined a cluster. But what happened? How do we know what's happened when it hasn't joined that cluster yet? Can we find out where that thing went wrong? So we're going to be doing some experiments, some research into finding out how we can do that through the various infrastructure APIs that are given to us. Load balance providers. So this is definitely nothing to do with Kubernetes services or service type load balancer. We're talking purely in terms of load balancers, the Kubernetes API server. So before you've even got a cluster up, you want a load balancer to those various control plane instances. So we're looking at a pluggable model to be able to do that, and that's really important for the on-premise environment where you don't typically have those cloud provider constructs like the Elastic Load Balancer, etc. Moving machine pool out of experimental, so complete the implementation for AWS primarily, and make sure that that abstraction works across the various different types of public clouds. Support for Windows nodes. So there's that's going to start off with one of our sister projects called Image Builder, which provides mechanisms to build images for the various Linux distributions, adding support for Windows to that, and making sure that we have a Windows-specific bootstrap provider that can bootstrap Windows nodes, essentially. And then finally, particularly for AWS Azure, we're interested in how do you deal with multi-tenancy. So with AWS and Azure in any large organization, you're not just dealing with one AWS or Azure account. It's going to be lots of different accounts and subscriptions, and you want to provide a single place where people, where teams can manage their clusters. So we need to provide native ways to be able to choose which accounts and subscriptions with the right levels of security around them. So that's what we'll be working on next. So if you'd like to get involved, then you can join us in our weekly meeting, which happens every Wednesday at 10 a.m. Pacific time. That's 1700 UTC. And not only, this is just for the main Cluster API meeting. And what you'll find, if you go to that link, you'll find that each provider has their own meeting specific to those concerns. AWS, Azure, vSphere, OpenStack, etc. So go and take a look and see what takes your fancy. Please join us. With that, I think we're done. Thanks.
All right, that was a lot of information. I'm sure a lot of people have questions. So Naadir is here on the phone as well. And we're going to try to go through as many questions as we can, but there are a lot. So if we can't get through all of them, we're happy to continue the conversation in Slack. And you can find us on, there's a thread already, I think, in the KubeCon Slack, CNCF Slack under maintainers, the maintainers track. Okay, so I can take the first one. Can Cluster API detect and reconcile node issues such as dead machines? Yes, so that's where you'd use a machine health check. So you can define a machine health check on your in your template, and that will have conditions under which the node is considered unhealthy. And when those conditions are met, Cluster API will go ahead and get rid of that machine and replace it with a brand new one. Naadir, would you like to take the next one?
Yeah, sure. So the question is, how can you use Cluster API to manage clusters running in private networks in the VPC? So it's about using Cluster API in AWS. So in that environment, you're going to, because Cluster API is doing a lot to interrogate the status of clusters, we do need to be able to connect to the control plane endpoint. So if you're running private VPCs, you are going to have to provide some sort of connectivity between them. So whether that's using VPC peering, direct connect, VPNs, etc. One of the things that we're looking at in the future is there's an upcoming project called AWS Controllers for Kubernetes, which is going to be managed by AWS, which will allow us to consume arbitrary AWS resources directly in a Kubernetes way. That might provide a mechanism to be able to automate some of that VPC peering. It's a bit hard to put all the different permutations of networking directly into the Cluster API provider AWS. Today, you can build different clusters. You will need to use some other automation to sort out the networking between private networks.
Thanks. Okay, I can take one. Is there tooling for the bootstrap process of self-managed cluster? Yes and no. So there is some commands in clusterctl. Clusterctl is the tool that Naadir was using in the demo, which is the CLI tool that was built to facilitate the management of the Cluster API management cluster. And that does have an ability to move all your resources to make essentially any cluster self-managed. So if you build a bootstrap cluster and then you build a target cluster, like a Cluster API built cluster with that target cluster, then you can then use clusterctl move to move all the Cluster API resources from that original bootstrap cluster to the target cluster. So then that target cluster becomes self-managed. I know there's also talks, there's an open issue, I don't remember the number off the top of my head, but about having some declarative management of the cluster itself, so you can have a self-managed cluster from zero to self-managed cluster. So that's still in the talks. And I would expect also any platform that builds on top of Cluster API to be able to automate that. Cluster API is really a building block, so you can do a lot around it.
Yeah, and that leads quite nicely into another question here around what would be the benefit of Cluster API over using providers such as EKS Cecile. So actually there's work going on right now to bring EKS support to Cluster API provider AWS. And one of the reasons that's happening is to allow that sort of GitOps model to manage clusters for people who are using EKS today. So using EKS Cecile to manage clusters right now, you'll be able to do that declaratively using Cluster API, hopefully by the end of the month. And related to that, if you're to be able to that bootstrap cluster that you're creating using Cluster Cecile on the command line, that's really about using that Cluster Cecile move to make that a more permanent self-managing management cluster. And then from there, you can drive all your nice GitOps for all the other clusters that you want to manage.
Yeah, that's a great point. So how can you get involved in the development of Cluster API? I love this question. So we'd love for you to get involved. And I think the best way to start is to join the different communication channels. So you'll want to join the Kubernetes Slack if you're not already in it. And there is a dedicated Cluster API channel. And there are also channels for each provider. So if you're interested in a specific area, let's say Azure, you might want to join the Cluster API-Azure channel. And there's one for every provider. And then you should also join the Cluster Lifecycle mailing list, which will give you access to all of the documents, including the meeting notes and everything. There are links for that on the Kubernetes community repo if you go under SIG Cluster Lifecycle. And also, as Naadir mentioned earlier, we have a meeting every week. So that's a really good way to start getting to get to know the community, and you can just join and listen if you're just want to learn more, or you can come and ask any questions you have. And that happens every Wednesday at 10 a.m. Pacific time. We're actually not going to do it today, I think, because of KubeCon, but the next one would be next week, a week from now, on Wednesday. So look forward to seeing you there. And then we also have good first issues on the repo. So that's also a good way on any Cluster API repo, whether it's a provider repo or the main Cluster API repo. So if you filter GitHub issues with labels, you can look at the good first issue labels, and those are usually well-scoped small issues that are good to get started with. I don't know if Naadir, you have anything to add to that?
I think it's one final question about how does Cluster API relate to other projects, such as MetalCube or Ironic or Tanzu. So these are all, Cluster API is very much a building block, and we fully expect people to build other things on top of it. MetalCube is an example of using Cluster API to provision to bare metal. Tanzu is involved in provisioning, using Cluster API to provision to vSphere. So it's very much a fundamental building block. We just want to solve the problem about deploying Kubernetes once and for all. We've been doing it for 4 years. Let's just join together, do it well together, and everyone can reap the benefit.
Yeah, I'll try to squeeze in one more answer. Does it support EKS in AWS? So there is an in-progress PR actually to add support for building EKS clusters. And that's something that's come up a lot recently, like how do I build managed clusters with Cluster API? It is still very experimental and very much in the development process. So if you'd like to help shape it, this is a great time. You can find the PR in the Kappa repo, which is Cluster API AWS. And then we also have done something on the Azure side. There's an experimental feature available for deploying AKS clusters. So that's already available in the latest release under the experimental folder. So check that out. All right, I think that's our time, Naadir. Yeah, thank you for joining. We're happy to continue the conversation in Slack. Sorry we didn't get to all the questions, but I'll see you all in Slack. Thanks.